Okay, for some time I'll discuss some questions from harmonic progression, then I'll clarify your doubts in the mains material. Am I audible to all of you?
Yes, sir.
Yes, sir.
Yes, sir.
Okay,
Yes.
all right. Okay, so let us continue. I think up to 23rd we're done in the class. 25 onwards we have to do. Okay, H is a harmonic between A and B, and we have to prove 1 by H minus A plus 1 by H minus B is same as 1 by A plus 1 by B, which is also same as 2 by H. This part is already proved, we know that. Okay. Only regarding this part we have to see. We know what is H, and we can substitute it and we can do it, I guess. Okay, so this is already known because this is a definition, nothing to prove there, and H is 2AB by A plus B. Only from here to here or from here to here we have to prove it. Okay, let me start with 1 by H minus A plus 1 by H minus B. Now directly substitute this, you'll get 2AB minus 2AB by A plus B minus A plus 2AB by A plus B minus B. When I expand this, A plus B will come on the top. Here 2AB minus AB is AB minus A square. This is also A plus B in the top, AB minus B square. I can take A common, I'll get B minus A. I can get B common, I'll get A minus B. So I'll take minus common. So I'm going to take A plus B by B minus A common. Then I'll be left with 1 by A here. I'll be left with minus 1 by B here. This is B minus A by AB. This and this will cancel. You got A plus B by AB, which is 2 by H. Apart from proving, I'm not fully sure how somebody could make a question. Of course, by simplification, they can make a question. What is the big deal? But is it something else also there? Okay, just copy this. It is also 1 by A plus 1 by B also we got here. Okay, just substituting harmonic mean and simplifying, that's all, nothing much further. All right, we'll go to the next question. Okay, 27. I think if you know H1 and if you know Hn, we can prove this. Between A and B, n harmonic means are inside H1, H2, H3, Hn. They want us to prove some particular sum is 2n. H1 plus A by H1 minus A plus Hn plus B by Hn minus B is 2n. Okay, so first harmonic mean, what is the formula we have? 1 by H1. If you take a reciprocal there in AP and divide in the ratio 1 is to n, I'll be getting 1 is to n plus 1, sorry. One is to n only. Okay. So 1 into 1 by b plus n into 1 by a by n plus 1. They want h1 by a and I have to apply component derivative to get this. So I'm going to multiply with a. So I'll get multiply with a and then take reciprocal. First of all, this is na nb plus a by ab into n plus 1. Okay, this a up and then reciprocal. I'll get h1 by a as b into n plus 1 by nb plus a. Okay, even split it. nb plus b by nb plus a. By applying componendo dividendo, h1 plus a by h1 minus a. And I add these two, I'll get 2nb plus a plus b. And subtract these two, b minus a. Similarly, 1 by hn, when I take reciprocal and apply section formula n is to 1, I'll get harmonic mean n to 1. That is 1 into n into 1 by b plus 1 into 1 by a by n plus 1. That will be na plus b by ab into n plus 1. They want hn by b. So I can take this b up and take reciprocal. So hn by b is na plus a by na plus b. Second componendo dividendo hn plus b by hn plus a. Sorry, minus. And I add these two, 2na plus a plus b. And when I subtract a minus b. Now I need to add these two. So when you add these two, denominators are more or less same with a minus common. Okay. So I can keep it as a minus b only. Then this will come minus. So minus 2nb minus a plus b. That one as it is 2na plus a plus b. Minus a plus b plus a plus b will cancel. Take 2n common. A minus b will cancel. We'll get 2. Okay, so nothing much here. We have to know how to find the harmonic mean. Find the first harmonic mean and then substitute here. Find nth harmonic mean, substitute here and simplify, you will get it. That's it. I think it is only algebraic manipulation. Maybe one or two times we can get some graphical idea about it. Maybe here I don't know. Is it clear to everyone?
Sir.
Yes, sir.
Okay. Those completed, you can try the next question. Okay, everybody completed?
Yes.
Yes.
Yes, sir.
Okay, 29. ABX are in AP, APY are in GP. They want us to prove 4Z X minus Y minus Z is equal to Y into X minus Z whole square. A, B, X are in AP. A, B, Y are in GP. A, B, Z are in H. Of course, we know what is X and what is Y, what is Z in terms of AP. You can just substitute, we will get it. Otherwise, can we do something? I want to divide Z square here and Z square here, so that at least 1 by Z I want to substitute. When I divide with Z square, I'll get 4 into X minus Y. I'm divided with Z square here and Z square here. Then that Z square will divide here. I will get Y by Z minus 1. And here Y into X by Z minus 1 whole square. Instead of proving this, I can prove this. Okay, so from this plus this is 2 times this, so 2b is equal to a plus x. So in the place of x, I can simply write 2b minus a. In the place of y, ay equal to b square. So I can write y as b square by a. And 1 by a plus 1 by z is 2 by b. So 1 by z, I can write 2 by b minus a. Maybe just a matter of substitution. If I take only LHS, 4 into x minus y into y by z minus 1. 4 into what is x minus y? So good. 2b minus a minus b square by. What is y into 1 by z? That is product of these two. When I multiply these two, 2b by a minus b square.
Sir,
Yes, you want to give an idea?
sir, no, sir. 1 by z equal to 2 by b minus 1 by a.
1 by z equal to
2 by b minus 1 by a.
1 by a. This is 1 by a. Oh, thank you. So when I multiply this, it is b square by a square. If I get b square by a common, will it become some perfect square? I can just expand, but let us just
Sir,
trying only.
-1.
What is minus 1? I forgot minus 1 you're saying. Okay, thank you. Then these two, I think, unless we take from 1 by a common, they're more or less same. Okay, divide with a, this will come. Divide this with a, this will come. Divide this with a, this will come. Okay. So right here, you can put maybe something. Divide this with a, this will come. Okay, so this is at least a perfect square, and we want x minus z. Okay, so understood that these two are same unless for a. Okay, so for a into I can write to 2b by a minus b square by a square minus 1 whole square. Is this part exactly x by z? No, this is already y by z. Now, what is y b square by a? So if I want y, I should take b common, so that I'll get b square. B by A I should take common out of this. Right here I can take LCM or B by A common. So, or you can just find LHS or RHS, leave it. This is LHS. This is RHS. So RHS is y into x by z minus 1 whole square, and y is b square by a. X by z, I have to multiply these two. This into this is 4. This into this is minus 2b by a. This into this is minus 2a by b. And this into this is plus 1. And there is a minus 1. This one and this minus 1 will cancel. And we wanted to take a inside. Okay. I can write a into b square by a square. This part is, you can take some 2 common. There is a 4 here, so I did not, I have 4. Okay. So I can take 4 also common. Not 4 only. Yeah, 2 square common. I'll be left with 1, 2 minus b by a minus a by b wholes. This 2 square is 4 and it will become 4a. And I would have taken LCM here and put both equal also good. Then trying to get that. Just a minute. Okay, here if I take LCM, it is 2ab minus a square minus b square. Oh, that is a perfect square by a. That is also if I take LCM, 2ab minus b square minus a square by a square. That is 4 by a cube. This is also a square plus b square minus 2ab, a square plus b square minus 2ab. That is a minus b whole power 4. Okay. This one b square by a square. B square by a 2 common 2 square, and then LCM will be 2ab minus b square by ab whole square. This is again a minus b whole power 4. There is a 4. This is a square b square. 1 b square will cancel. And a cube will come. 4 by a cube a minus b whole power 4. But it's just a matter of simplification. I am not so happy. We got the answer. Nothing wrong. LHS and RHS are equal. I just took 1 by z so that 1 by z is easy to know. Otherwise, we also know z. Okay. I'm not fully happy with the solution where I just found LHS, RHS and equated. How somebody got an idea of some adjustment. So is there any other way? I'm not clear about it. All right, for the time being, it's okay. If I get any other idea, I'll tell you. Both are same. LHS equal to RHS.
Sir,
Yes, please.
sir, once can you share the screen, sir?
Okay.
Yes. Thank you.
Anybody any doubt regarding 29? All right. Actually, in revision, I should give you more time for you to practice. Okay, if it is a physical situation, I would have just standing in the class, I would ask you to try. If somebody has doubt only, I would to explain. But in this situation, that will go like this. If you completed one question, you can always try the next question, or at least next order. I'm giving some time. You can try 31. Next, you can try 33 also. Okay. Okay, I'm still thinking about this 29th question. I did not get it, but basically the question what it says is you have to find relation between XYZ eliminating AB. Okay, because in the final answer there is no AB. Okay. So after getting this, let us say they did not give that and they wanted us to eliminate A and B. How are we going to do it? I'm just still thinking. Of course, somebody can say I'll solve these two or solve first and last, find what is A, what is B, and put it in the second one. Maybe it will come, but not sure. Because these are two equations, two unknowns, but directly eliminate B will get a quadratic equation in terms. Okay. Somehow we have to combine and get an idea how to eliminate AB from these three equations and find relation between X, Y, Z, which is the final answer. All right. Let's see later. Okay, 31. They want difference between nth harmonic mean and first harmonic mean, right? So between A and C, H1, H2, so on to Hn. Is it automatic mean or harmonic? And harmonic means are inserted between A and C. What is the difference between the first and the last mean? That's it. Okay. So 1 by A, 1 by H1, 1 by H2, so on up to 1 by Hn and C. They are in A. These are in A. We have formula for each one of them, of course. This minus this is the common difference, but we want H1 minus Hn. So if I take Hn minus H1, both of them formulas are there. Let's now we compare back. We wrote Hn is 1 by n times 1 by b plus 1 by a by n plus 1. H1 is n times 1 by a plus 1 by b by n plus 1. So b now it is C. Okay, you can take n plus 1 AC by NA plus C, n plus 1 AC by NC plus C. Now you can take n plus 1 AC common and then Na plus C and that is LCM. NC plus C minus Na plus C by Na plus C into NC plus C. NC minus C, n minus 1 AC will come. This is n minus 1 C, this is minus n minus 1 A, n minus 1 into C minus C. Okay, so n plus 1 into this also C. AC. This is n minus 1 into C minus C by Na plus C into NC plus C. They wanted us to prove, I think we cannot do anything much about it unless they gave some quadratic equation there. Let us just try to use that. That is 1 minus AC into n square minus a square plus c square into n minus 1 plus ac equal to 0. I think this quadratic equation is made up just to write this answer without n, that's all. Okay. I'm sure the product of these two will be found somewhere here. When I expand this, we'll get n square minus n square ac minus a square n minus c square n minus 1 minus ac equal to 0. I think these four and this together is this product. This into this is n square ac. This is NAC. No, n square n a square. That is this n c square plus a c. Yeah, that is 1 plus n square is also there for us. 1 minus n square in the numerator. Okay, the quadratic equation is just a way of giving to remove n here and write in terms of AC. That's all, nothing much, I guess. To prove that is 1 maybe. Yeah, that's all. If you actually see carefully, that is n square minus 1. And this one, when you expand, is n square AC plus n a square plus n c square plus AC. The other part is AC into C minus C. This to prove 1, they just gave this. That's all. This is not any, I don't think any conceptual in that. Send all the negative terms that side except for minus 1. We'll get n square AC plus a square n plus c square n plus 1, which is exactly, no, plus 1 is that side of minus 1. Which is exactly, this becomes 1 because these two are same, and we'll get the answer. That's it. Now this becomes 1. Okay, AC into C minus. Okay, these questions, at least some question doesn't teach anything much. The only thing you have to know is it is some question based on harmonic means. Just they ask the difference, I found the nth harmonic mean and the first harmonic mean and found the difference. I cannot do anything about it. It has to be left like that. Just to tell that this value is 1, they equated to 1 and the cross multiplication and they created a quadratic equation. If they would have equated this to 5, I'm sure we'll get some other quadratic equation. You can give that also and say so that this is 5 AC into C minus. Okay. So nothing so great. Especially when you try these questions on your own, the advantage will be you are using nth harmonic mean, first harmonic mean so many times that in the future also you'll be able to write quickly. Okay, next you have to try 33 and 34, of course, we already thoroughly proved in the class. So later on you write out of the 3 solutions that I gave, any one solution you can. So, the completed, please try 33. Okay, 31, everybody completed? Okay. Okay, 33, anybody want to give any idea? In some of the terms like a1 minus a whole square, a2 minus a whole square, and an minus a whole square, they subtracted mean from each number, they squared and added. Okay, that is somewhat like a variance, but does it? It looks like one form of variance to second form of variance. Is it that or is it something else? Okay. Apart from solving, I just want to first of all, A is a1 plus a2 on to an by n, arithmetic mean of n numbers. They wanted a1 minus a whole square plus a2 minus a whole square plus an minus a whole square. Somewhere it is there. If you take by n, that is variance formula, and another formula for variance is sigma ai square by n minus of mean whole square. That is a square, which is going to benefit in any way. So if I take this n inside, of course, just simply by expanding, I can get that. We also have to get a1 b1 plus a2 b2. Okay, let us just expand this. I'll get a1 square plus a2 square so on up to an square minus 2a common a1 plus a2 so on up to an. This all the 2ab terms are included plus na square. A square plus a square plus a square is na square. I don't think I can do anything about a1 square plus a2 square so on up to an square. This is n times a plus na square. So minus 2 na square plus na square will be na square. So a1 square plus a2 square, so on up to an square minus na square. So what can we do after this? We wanted a1 b1. Of course, a1 b1 can be written as a1 into 1 minus a1 because b1 is given as that. Okay, let us do even that and see what happens. If I take only a1 b1 plus a2 b2 so on up to an bn, I am going to get a1 into 1 minus a1, a2 into 1 minus a2, so on up to an into 1 minus a. That is a1 plus a2 so on up to an minus a1 square plus a2 square so on up to an square. This is n times a minus a1 square plus a2 square so on up to an square. Of course, between a and b also one relation is there. I think I can say because ai plus bi equal to 1, when I take all of them and take the average, I should get a plus b also equal to 1. Am I right?
Yes, sir.
It's like a saying, it's okay, we can easily prove it. A1 plus b1 equal to 1, a2 plus b2 equal to 1, an plus bn equal to 1. Add, we will get sigma ai plus sigma bi is equal to n. When you divide, you get a plus b equal to 1. Okay. Now this is the LHS, and this is at least part of RHS. If we add these two, we want to get NAB. Yeah, we are getting that. Okay, so the right side negative times I'll bring left side. Let me add this. Okay, this plus this and prove it is NAB. That's it. NA minus NA square is actually NAB. If you recognize that A plus B equal to 1. Yeah. That's so a1 minus a whole square plus a2 minus a whole square so on up to an minus a whole square plus this one. So I'm adding this and this plus a1 b1 plus a2 b2 so on up to a and b is na minus na square, which is na into 1 minus a, which is nab. Yes. Okay. You're also just manipulating the algebra, that's all. And indirectly recognize that a plus b is 1. You have to recognize it. Those who can complete, those who completed 33, try 35, think about it. Okay, basically 35, what happens in the question is, let me take an example. I'll take 1 minus, no, I'll take minus 1 and 2, minus 4, minus 7, minus 9, 5, 8, 11. So, look at this. Is this an, no, this is minus 10, minus 30. Is this an arithmetic progression?
Yes, sir.
Yes.
If this is an other, and there is a decreasing AP. If an AP is decreasing, when I take reciprocal as HP, what will happen?
It is increasing.
No, that is wrong.
Sir, means decreasing and increasing, sir, because negative is there.
Yeah, if all are positive, if they're increasing, the reciprocals will be decreasing. And if all are negative, it is decreasing, I think the reciprocals are also decreasing. Okay. Here, this is decreasing, reciprocals also will decrease. This increasing reciprocal. Okay, we'll see what happens. We take minus 1 by 30, minus 1 by 10, minus 1 by 7, minus 4, and minus 1. Reciprocals. What are those values? Are increasing or decreasing?
Increasing, sir.
They're increasing. Okay. Next, when I take this one, 1 by 2, 1 by 5, 1 by 8, 1 by 11, what is happening?
Decreasing, sir.
They're decreasing. So, even though this whole thing is decreasing, when you take reciprocals, this part is increasing reciprocal up to some extent as long as they're negative and then decrease. If something is increased and then decreased, will it have a maximum value?
Yes, sir.
Okay, just a minute. What if I took a decreasing one? What if I had taken increasing? What's the question there? They wanted largest positive term. Yeah, because it's decreasing, the first positive term will be the largest positive. Yes. Anyway, actually, don't have to worry about negative part at all then. Don't worry about this. Okay. Okay. Or some negative numbers are there. So if they are negative numbers, their reciprocals also negative numbers. Okay. And the positive numbers, because they're increasing, the reciprocals will be decreasing. So the first positive term, whatever it is, the reciprocal of that is actually the largest positive term. All others are less than that. So there, if you see carefully, you will find somehow initial terms are negative, later on positive. Now think about it. We can discuss in the. I don't know if tomorrow we'll discuss because past year mains questions. Okay, I think up to 20 I discussed. By tomorrow, at least 60 or 70 I can discuss, right?
Yes, sir.
Okay. So minimum up to 60 I'm going to discuss. If possible, we'll see more also tomorrow. All right. Thank you.
Thank you, sir.
Thank
Thank you, sir.
Yes, sir.